Hey guys, this is the reteaching video for Q4 Week 7, Unit 3, Lessons 4 and 5 cool down. So for question 1, here we have a scatter plot and it's asking what is the slope of the linear model. So up here in the description, it has the equation in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. And m is the slope. So here we can see in the equation that the m is actually 1.5 because it's the number that's being multiplied by the x. So here my slope is 1.5. This 22.7, that's your y-intercept. For number 2, same scenario. It says, what does the slope represent in terms of maximum noise level and the number of people in the stadium? So as we look at our labels for our scatter plot, the x-axis is number of people in thousands, and the y-axis is maximum noise level in decibels. So my slope, remember, is a rate of change. And when I talk about rate of change, I'm talking about the change in y over the change in x. So that means how much does the noise level change per number of people in thousands. So as you can see, our slope is an increasing slope. It's going up. So that means that the noise level is increasing by 1.5 per number of people in thousands. So that would be explained by that one. How much the noise level increases per 1,000 people. For question 3, you're supposed to choose the scatter plot that shows data that would best be modeled with a linear function. Linear means line. So which one of these scatter plots shows data where the dots look like they make kind of a line? So here we've got a whole bunch of dots everywhere. That doesn't really make a line. Here it looks like my dots are in the shape of a curve. So that's not really linear. But this one down here, these dots make roughly a line. So we're going to go ahead and choose that one. Okay, for number 4, it says, which of the lines is most likely the line of best fit for the data provided? So here our choices are in the form of equations. So I have to look at these and look at the slopes and the y-intercepts and decide that way. My hint to you is it's probably easiest to figure this out looking at the y-intercepts. So that's these numbers over here. Remember, a y-intercept is where my line of best fit would cross my y-axis or touch my y-axis. So a line of best fit roughly is going to look something like this with this data. And so I can kind of tell that a y-intercept of 225, which would be like way up here, is way off. That's not going to work. A y-intercept of negative 34.05 would be like way down here in the negative area of my graph. So again, I don't think that really is going to work. For the next one, my y-intercept is negative 0.19. So that's just below the 0 here. And that one seems pretty reasonable for that line of best fit. This one is all the way down at negative 21, which would be like kind of down here in this area. So I think, again, that's probably a little too low. So we'll choose the third one. And then what's the weirdest thing you ever ate is your fun question. And then don't forget to get your free 6 points. Did you complete this cool down? So your access code for your redo is FIT. FIT, fit, as in line of best fit.